You already know how Megalodon killed. It came up from below and hit the chest. It crushed the ribs, the heart, and the lungs in one strike, and the whale bled out. Every telling gives you that. Not one of them is built on a fossil. This is a fossil. It is a tailbone. It belonged to a long-snouted dolphin, a kind that no longer exists. That animal swam off the coast of Maryland more than 15 million years ago. There is a gouge cut into one side of it. There is a second gouge on the other side, directly opposite the first. Something closed around this bone and held it. The edges are still sharp, the bone never healed. The story says the chest. The evidence is a tail. This codex opens on the question almost nobody asks about Megalodon. Not how big it was, not what killed it. Where on a whale's body did it actually bite? Ask that, and the confident answer thins out fast. Megalodon left no skeleton. A shark's frame is cartilage, and cartilage rots. Almost everything we can prove about how this animal hunted has to come off the bones of the animals it bit. Today, we count those bones. Every marked specimen that can say where a strike actually landed. We name each one, the drawer it sits in, the rock it came out of, the people who described it. Then we mark the line out loud between what the bones measure and what we are guessing. Before we go anywhere prehistoric, anchor this in today. Off Seal Island, off Guadalupe, off the Neptune Islands, we can put a satellite tag on a living white shark and fly a drone over it while it hunts. We have high-speed footage. We have decades of field notes. Even with all of that, the strike itself is a half-second event under the surface, and researchers still argue about where on the seal the first bite lands. Hold that against an animal nobody has ever watched. Otodus megalodon. A study led by Kenshu Shimada in 2025 put the largest defensible estimate at 24.3 meters and around 94 tons, roughly the length of 2 city buses parked nose to tail. The same study rebuilt its shape. Not a scaled-up great white, closer in proportion to a lemon shark. Long, slim, built like the other giants of the sea rather than like a modern hunter of seals. The one number everybody quotes is the bite. In 2008, Stephen Rowe's team modeled a shark jaw in 3 dimensions and scaled the result up. They landed between 108,000 and 182,000 newtons. It is one of the hardest bites ever estimated for anything alive or extinct, and it is the reason the crushing story feels obviously true. A bite that strong should be able to end an animal anywhere on its body. Here is what we do not have. No skeleton, no stomach contents, no footage, no witnesses, no bite recorded by any instrument. Teeth fossilize beautifully. A few vertebral centra survive. Behavior does not fossilize at all. It survives in one form only, as damage on somebody else's bones. Almost everything in this story comes out of 3 stretches of rock. The Calvert Cliffs on Chesapeake Bay, a phosphate mine at Lee Creek in North Carolina, a stretch of desert in southern Peru called the Pisco Formation. Each of the 3 was a shallow sea once. Each one now gives up whalebone by the crate. A small share of that bone is chewed, and that share is the whole subject of this video. The world it happened in ran from the Middle Miocene into the Pliocene, roughly 16 million years ago down to 3. The prey was not the giants we picture. Dolphins, seals, sea lions, baleen whales, the length of a small boat. The standard telling puts a wrecking ball among them. It ambushes from below, rams the ribcage, and crushes everything inside in a single pass. That version is a claim about a body we have never found, performing a behavior nobody has ever seen. The chewed bones are the only witnesses in the building. There is a problem with the wrecking ball picture, and it starts with where the picture came from. For most of the 20th century, reconstructing Megalodon meant one move. Take a great white, scale it up. Same broad body, same thick torso, same hunting style, 5 times the size. The jaw mounts in museum halls were built on that assumption. The photographs of people sitting inside those jaws went around the world. The documentaries followed. So did the film that dropped a diver in a cage in front of it. The ram and crush strike is borrowed from the same place. White sharks at Seal Island do accelerate straight up into a seal and breach clear of the water with it. That behavior is filmed, measured, and published. It is also a 2-ton shark hitting a 50-kilogram animal. Copying it onto a 90-ton shark hitting a 5-ton whale is not evidence. It is a guess wearing evidence's clothes. Shimada's 2025 study takes the borrowed body away. The proportions point to a long, slim animal, nearer a lemon shark than anything that hunts seals in surf. The same work put the cruising speed at 2.1 to 3.5 kilometers per hour. A person on a footpath walks at 5. Cruising speed is not attack speed for any shark. What it tells you is what the body was tuned for, and it was tuned to cross ocean cheaply. The skeleton is the harder objection. A ram strike is a collision, and a collision has to be braced against something rigid. Megalodon's frame was cartilage. It stayed unmineralized down most of its length, which is exactly why almost none of it fossilized. The animal that supposedly drove itself through whale rib cages had nothing solid behind the blow. Here is the part worth sitting with. The specific image, a shark using its own body as a projectile, is not something the literature ever established. Paleontologists argue about bite force and about which bones got bitten. The high-speed collision is a caricature we inherited from posters and film, and it hardened into fact by repetition. There is no rammed whale in any drawer, anywhere. The strike everyone describes has never been found. What the teeth suggest is different again. The largest run past 18 centimeters, a handspan from a grown adult. Every edge carries fine serrations, and the crown is broad and flat rather than spiked. Spiked teeth grip and hold the way a crocodile's do. Flat serrated blades shear. This animal was armed to remove parts of things. In 2018, 4 researchers published 3 bitten bones in Acta Paleontologica Polonica. Stephen Godfrey, a museum curator, with 3 fossil collectors, Mike Elwood, Stephen Groff, and Michael Scott Verdon. Remember Elwood. All 3 bones sit in one museum, the Calvert Marine Museum, and all 3 are tailbones from long-snouted dolphins that are no longer with us. 2 came off Calvert Cliffs in Maryland, out of the Plum Point beds of the Calvert Formation. The 3rd came out of the Lee Creek Mine at Aurora, North Carolina. Hold on to that mine. Each vertebra carries gouges on both sides at once. The spacing matches the gap between 2 neighboring teeth in a megatooth jaw. That reading is mechanical, not poetic. The bone went into the mouth. It jammed between 2 adjacent teeth as the jaw closed. Not a graze, a grip. 2 details matter more than the marks. The bites sit on the peduncle and the far end of the tail, the narrow drive shaft that turns muscle into forward motion. And not one of the 3 shows any healing. Healing matters because bone is a clock. Injure a living animal and the surface starts remodeling within days. Sharp, unremodeled edges mean the animal did not go on living. The author's conclusion sits in their abstract in plain words. Bite marks in that position suggest active predation rather than scavenging, in order to immobilize even relatively small prey before consuming it. Read as a strategy, that is not a wrecking ball. A bite to the tail takes no vital organ. It takes the ability to leave. The paper is careful in one more way, and we will be too. It does not name Megalodon alone. The bites are attributed to Megalodon, or to Carcharocles chubutensis, the older megatooth shark it followed. The teeth are close enough that a gouge cannot always tell you which mouth made it. Keep that in your pocket. The living control is almost too neat. In 1991, in Fishery Bulletin, Douglas Long described a pygmy sperm whale, 1.8 meters, alive, stranded in central California with white shark bite scars across the anterior caudal peduncle. The tail base. Same body part, a living ocean, a shark a fraction of the size. The other side of the world adds the prey. In 2017, Alberto Coloreda's team described bitten bones from the Pisco Formation at Aguada de Lomas in southern Peru, the skull and ribs of Piscobalaena nana, a baleen whale around 5 meters long, plus seal and sea lion material. It was the first time a megalodon prey animal was named down to species. One caution belongs here, and it is the one every other telling skips. Bone is a small target inside an animal. Most bites land in flesh and leave nothing behind to find. The marked bones are not a survey of how Megalodon fed. They are the handful of cases where a tooth happened to reach something that lasts 10 million years. Here is the part the bones will not settle. It comes out of the same museum, found by the same collector. Mike Elwood, the volunteer collector who found one of those 3 tailbones and is a co-author on the study, also pulled a whale vertebra out of the Calvert Formation. The animal was small, about 4 meters. The rock is roughly 15 million years old. In 2022, Stephen Godfrey and Brian Beatty published what a CT scanner found inside it. The bone had failed under one violent load, a shear compression fracture. The lower 2/5 of the vertebra sheared away from the rest and shattered. That is a whale's back breaking. Then the scan showed something better. The membrane that wraps living bone had gone to work, and the fragments were knitting back together at the time the animal died. This whale was not killed by the blow. It swam on with a broken back for weeks. A megalodon tooth turned up nearby with its tip broken off. It is a tempting object. It also proves nothing about this whale. The two were never found in contact. And then the authors do something no documentary will ever repeat. They argue against their own headline. A whale seizing violently can break its own back, and whales do seize. Domoic acid, the toxin behind harmful algal blooms, still causes convulsions in sea lions and dolphins off California every year. Shark or poison? Their paper leaves both explanations standing, and the honest answer is that we cannot separate them from one bone. There is a second survivor, and it comes from that mine. In 2012, Meredith Kalal, Stephen Godfrey, and Donald Ortner described a Pliocene whale rib out of the Yorktown Formation at Lee Creek, the same pit that gave up the 3rd tailbone. 3 tooth marks, spaced about 6 centimeters apart. Megatooth geometry. The surface is not a clean slash. It is remodeled, bone grown back over the wound. That whale lived too. Survivors matter more than they sound like they should, because of a hole in this kind of evidence. A bite mark on a bone cannot, by itself, tell you whether the animal was hunted or already dead. Sharks scavenge, and a drifting carcass draws them for days. Every unhealed mark in the record carries that doubt. A healed wound removes that particular doubt. Bone only rebuilds in an animal with a heartbeat, so whatever made these marks, it happened to something alive. The Lee Creek rib is the cleanest case. Tooth marks, healed over, an animal that survived being bitten. The Calvert vertebra is the same shape of story, if the shark did it. Both are body hits. Both animals swam away. A predator that never misses leaves nothing behind that heals. Now lay the whole record on one table, because it is small enough to fit. 3 tailbones off the eastern United States, bitten through the drive shaft, and not one of them shows a day of healing. 1 vertebra with the back broken, healed, survived. 1 rib with 3 tooth marks, healed, survived. The bites on the tail killed. The 2 animals hit in the body lived. That is worth saying carefully, because the number is 5. 5 specimens is not a data set. It is a coincidence with a citation. It is also the only coincidence we have, and it points the same way as every living shark we can actually watch. Read it forward, and the animal changes. Take the tail, and a 5-ton whale in open water stops being a chase. It becomes a floating object. No vitals opened, no fluke left to break a jaw against, nowhere for it to go. Then feed at whatever pace suits you. That is not fury, that is economy. The same logic that makes a white shark bite a turtle beside the flipper instead of trying to crush the shell whole. It is also the harder version to sit with. A wrecking ball is stupid, and stupid keeps it safely far away from us. An animal that goes for the one part of a body worth destroying first is doing something we recognize, and we tend to reserve that word for mammals. None of this is a claim about a shark's mind. What the bones require is a pattern that worked, well enough to leave the same signature on 3 separate animals, on 2 coastlines, and across 10 million years, in the same narrow part of the body. Sit with the other half of that too. We can tag a living white shark, watch it from the air, film it at 1,000 frames a second, and still argue about where the first bite lands. Megalodon left no witnesses and no skeleton. It left gouges in the tail of a dolphin that died more than 15 million years ago on a coast that is now a suburb. This codex takes the drawer over the diorama. The drawer is smaller, and it is the only part of this animal that is actually evidence. What it holds is not a mindless giant, and not a monster with a plan. It is a predator that seems to have solved the oldest problem in hunting. The fastest way to end a chase is to end the swimming. The bone in that Maryland drawer never healed, and the 2 gouges still sit opposite each other, exactly as far apart as 2 teeth in a jaw that has been gone for millions of years. The monster we invented bites the chest. The one in the drawer took the tail. There is one hesitation left in the 2018 paper, and it is the last thing in the cabinets. Megalodon, or Chubutensis. The people who described those tailbones would not commit to one mouth, and that is the detail that undoes the word we have been using all the way through this. Lay the megatooth teeth out in order of age, and they do not hold still. Each crown starts with a pair of small side cusps at its base. Across millions of years, those cusps shrink. Then they stop appearing at all. The blade straightens. The serrations tighten. The thing we call Megalodon is the last version of a line that spent 20 million years rebuilding itself. And the teeth from the middle of that run sit in the same collections under different names. The question that comes next is not how it hunted, it is when it became the animal we have been describing. What was it before it was the monster?